Okay, flame photometry, flame emission spectroscopy. Flame photometry is concerned with the emission of characteristics radiation in flames by individual elements. Flame photometry is concerned with the emission of characteristic radiation in flames by individual elements and a correlation of emission intensity with concentration of these elements. Solution: and mist, evaporation, vaporization, gas, dissociation, thermal excitation, the gas. In case of AS, absorption, but in case of emission spectroscopy, thermal excitation. Absorption of radiation energy in case of AS. But all are the similar. Solution: nebulization means evaporation, and a solid and vaporization, gas, dissociation, and thermal excitation, flame emission. The procedure by which the gaseous metal atoms are produced in the flame may be summarized as follows. When a solution containing a suitable compound or the metal to be investigated is aspirated into flame, the following events occur. Evaporation of solvents leaving solids residue, vaporization of the solid with dissociation into constrained atoms, which initially will be in the ground state. Some atoms may be excited by thermal energy level of the flame to higher energy level and attain condition in which they radiate energy. The Boltzmann equation gives the relation between the ground state and the excited state, absorption and the ground state, and emission, the excited state. N1 over N0, G1 over G0, E minus delta E over KT, N1 number of atoms in excited state, N0 number of ground state atoms, G1 over G0, ratio of statistical weights for ground in excited state, delta E energy of excitation, K Boltzmann constant, T temperature in kelvins. Transition between two quantized energy levels from E0 to E1 correspond to the absorption of the radiant energy, and the amount of absorbed energy is determined by Bohr's equation. Delta E equal to E1 minus E0 equal to SB equal to SCB over lambda, C velocity of light, S Planck's constant, the frequency of light absorbed, lambda wavelength of radiation observed. Instrumentation: flame, sample, flame, and filter or monochromator, detector, amplifier, and readout. In case of AS, we have hollow cathode tube and radiation and atomization. In case of a flame and in case of AS, we have the atomization. Then after monochromator and detector and recorder, all are similar. Only in case of atomization, the flame, in case of the atomic emission spectroscopy. The basic components are flame, nebulizer, monochromator, detector, amplifier, filter, or readout. Nebulizer or Barnett system, the production of the gaseous atoms is the primary purpose of the nebulizer burner system. The flame source is made up of a variety of parts, including a pressure regulator, a flow meter for fuel and oxidant, an atomizer, and a burner. Acetylene, hydrogen, and propane are among the most used gases. Likewise, air, oxygen, and nitrous oxide are the common oxidants employed. The flame used in the flame photometer must be able to evaporate the liquid droplets from the sample solution, resulting in the formation of solid residue. So decomposed solid compound resulting in the formation of gaseous atom must have the capability to excite the atoms and cause them to emit radiant energy. Monochromators or filters, flame emission lines or bands are isolated using monochromators which allow them to pass through. Detector. The main function of detector is to detect the emitted light and measure the intensity of radiation emitted by flame by the conversion of emitted light into an electrical signal. Amplifier. It amplifies the signal from the detector which is received by the readout. Readout, it reads the data and gives the information regarding the metals quantitatively. Application of flame photometry. Flame emission spectroscopy is widely used in clinical chemistry, food, agriculture, environmental analysis, biomedical research, and pharmaceutical industries, and so on. Some of the major applications are: it has found wide application in biomedical research, clinical chemistry, environmental analysis, and nutrition analysis. It also used to determine alkali and alkaline earth metals in mining and metallurgy, pharmaceutical. It is used to determine the metal additive in lubricating oils. Determination of calcium and magnesium in cement. Estimation of sodium and potassium in glass. Lead estimation in petrol. Application for the analysis of water by determination of sodium, potassium, calcium to measure the amount of calcium and potassium in the soil, plant, materials, food and beverage. To determine the amount of metals such as sodium, potassium, calcium and lithium in samples of serum, urine and other bodily fluids. Advantage of flame photometry: rapid, inexpensive, and more convenient, simple method for quantitative analysis based on the flame analysis. Selective and sensitive technique up to a wide range, even parts per million to parts per billion range. Limitation of flame photometry: not applicable for the direct determination of metals. Liquid samples only can be analyzed, not applicable for the non-radiating elements such as carbon, hydrogen, and alloys, since these elements cannot be detected by a flame photometer. It fails to provide the information about the molecular form of the metals present in the analyzed sample. Difference between flow photometry and atomic absorption spectroscopy is: flame photometry or flame emission spectroscopy involves emission phenomena, but in case of the atomic absorption spectroscopy is it involves absorption phenomena. Radiation emitted by the excited atoms is related to the concentration. Radiation observed during the excitation related to the also concentration. Mainly used for the analysis of alkali and alkaline earth metal. Elements like aluminum, silver, gold, copper, cadmium, mercury, arsenic, etc. are analyzed by AS. Greater spectral interference, lesser in the spectral interference, lesser sensitivity, higher sensitivity in most elements in case of AS. So it all about the flame photometry or flame emission spectroscopy. Thanks for watching and request you all like, comment, share and subscribe. Thank you for patience. That is now bye-bye. See you again.